Hi guys and gals and kittens, and welcome to the I Need a Magic show. Here I have a little bit of an interesting little snippet of code. Let me show you. Basically what it does, it executes an internal slot. This slot is not a part of Magic. I need to emphasize this is one of the internal proprietary helper projects I have developed in order to create my own LLM. However, it basically takes a folder. It takes count, seed, filter. Filter can be http ::, comma, data, asterisk, comma, io, file, load, comma, get, nodes, etc. Or you can just put it at asterisk, at which point it's going to run through all of the slots, distribution. Here means even, it means it runs through every single slot and starts over again when it has done every single slot, minus the one that are in its exclusion filter. Max depth is the number of children nodes inwards recursively. Max slots is the number of slots to connect downwards with each other. And catalogs are basically catalogs of potential values, such as, for instance, list folder has 200 different example folders. It's like by random choosing from whenever it's using that slot, right? Now the point is, when I execute this code, I will in roughly 0.1 second create 1,000 hyperlambda files. Look at this. It wasn't even 1,000, it wasn't even 1 second. Now if I go to this guy and I refresh, and this is going to take ridiculous amount of time, I need to emphasize, because I have 600,000 files inside of one of my modules. So it's going to take 40-50 seconds. I'm actually surprised it actually doesn't kill my browser, because this thing is now creating a tree control using Angular with 600,000 nodes in the DOM. However, it actually surprisingly works. Now, of course, that was a complete irrelevant fact for you, just explaining why we're looking at this boring screen for a minute instead of me showing you the resulting code. However, once this is loaded, we can expand, etc. We can expand SLETT, and here we can find our 1,000 files. Now, this is 100% perfect code and 100% perfect description. Every single last one of my files. And they were created in less than 0.5 seconds. I created 1,000 of these guys. That means that I can create terabytes of data in minutes, right? It's all dependent upon how much space I've got on my hard drive. Literally, that is my only restrictions in regards to how many examples. Now, I've generated now 280,000 files of this, and combined with my 330,000 files from before, 280,000, I'm up to, I think the total amount is 586,000 files in total. However, the point being that this way of synthesizing data is something that is completely unique for Hyperlambda, my programming language. You see, back in 2013, I rediscovered metaprogramming. Metaprogramming is from the 1950s. It's as old as Lisp, and Lisp was invented in the 1950s. So, what is metaprogramming? Well, let me show you the prerequisites for doing what I did by, actually I think I got it here, snippets, and it's called analyze. No, it's not called analyze. What is it called? You know what, I think I got it here. Here I got it. Yeah, here I have it. Yeah. This snippet here. Let me execute it first to show you what it does. And this is a snippet you can copy and paste into HyperID in Magic, and you can execute and you can get the result. This is a common part of Magic. Right. Now, what this basically does, it loops through every single slot or function that exists in the system. Then it reads metadata, which I have associated with every single individual function function declaration in the system. So for instance, this slot called add, it has this description, and it has this input declaration. It must be an expression, right, with this description for that input argument. It is required. It is of type mode expression. It can tolerate any charge. That's the asterisk here. But it has to be a lambda object, and here's the description of etc., etc. Right. So this thing basically ends up producing 100% perfect code. Why? Because it does never combine two slots together that aren't actually compatible at the function signature level, which means that I'm capable of like hammering the LLM with approximately 300,000 unique combinations of slots, arguments, variables, and other slots. And every single configuration is 100% valid according to the rule set of the language. And when I combine this synthetically generated data with my existing intentional corpus of training data, then the theory at the very least is that this is going to create like 100% perfect training material, allowing me to, at the very least in theory, exceed the quality simply due to my amount of training data, because I can generate infinite amounts of training data, right? I mean, in 1 hour, spending like 20 cents on compute, I can dwarf OpenAI and Anthropic. I can generate terabytes of data for less than, $10, because I'm literally only paying for the electricity. And you saw the speed. I created 1,000 items here now. If I reload this again, and I execute it again, and this time let me do 1,000, but let me do max slots 4, right? 1,000 to 1,000 hyperlambda snippets. Now if I refresh this guy, I will see every single example that this thing generated containing up to 4 slots at the max. Now this is going to spend time reloading again, but when it's done, let's have a look at some of the last remaining files we just now recently generated. Now, while we wait for this, let's talk a little bit about meta-programming, because I was practically laughed out of Reddit 10 years ago when I started commenting there, proclaiming I had found this like new way of creating software based upon hyperlambda, right? And basically nobody really believed in my ideas. I suspect that will change later today when they see the quality of the LLM I'm about to produce now. But basically here now you see 4 slots, 1, 2, 3, and 4. And slots are completely randomly connected, but only at the edges in such a way that it only connects compatible slots that are compatible in the typing domain, right? You see, for instance, these slots create, okay, lambda to YAML. Okay, technically slots.get returns a list or a lambda object, right? So in theory, this could become YAML, even though it's going to be a ridiculous YAML. And then it converts that, lambda to CSV to lambda. Okay, this is like, it's string input. That's why it works, but it doesn't really work, right? And then it concatenates all of these CSV root records. Let's look at them. Okay, they become absurd. They become truly absurd without any intent whatsoever, right? But they still become valid training snippets. And approximately like 60-70% of them are actually, kind of like relevant, because they're describing inputs for one slot that are outputs for another slot that are relevant and that typically would be connected at some point. Like here you see it starts with val 89, then it decrements it with a step being 89. Okay, so it sets it to 0. And then it uses .days, which has a value of 34, to create a time span object with 100 static hours, and .days days, and .seconds as seconds. And then it returns that value. This is an example of a super high quality training data snippet. Why? Because it shows chaining of variables, math slots that decrements in place existing numeric values, and then the ability to create a time object that you're returning based upon partially variables and partially literals. So this is a super high quality training data according to theory at the very least. And the process of running this, I mean, how many do you want? Do you want to have 1 million? Right? I mean, if I now execute this, my machine's probably going to die, right? Because I don't have that amount of hard drive or something. But the point is, I can synthesize infinite amount of training data. And it's all based upon one that simple idea, which is this guy. And this guy produces 18,000 lines of JSON code. So this is 18,000 lines of JSON here, actually. And as you can see, it exhaustively documents every single slot and function that exists in the system. Here you can see validators, URL, signature, input, type, string, description, URL, value or expression, selecting the node or nodes to validate, value or expression, required true. This little piece of information basically tells my computer everything my computer needs to know about this particular function in order to synthesize data using validators.url, right? And that creates, I hope, using metaprogramming, an environment where I can dwarf OpenAI and Microsoft and Azure and Amazon. Even though I'm a lone single guy working out of my home, my freaking living room, I can generate 1 trillion times as much training data as OpenAI, Anthropic, Microsoft, and AWS, and these guys, Google even, has combined. And I can do it for $1. $1. Welcome to the power of metaprogramming.